Okay, in 4.5 we're going to solve exponential and log equations. This first one uses the property that if the bases are the same, then the exponents also have to be equal. So if we can rewrite the bases to be the same, then we know that the exponents have to be equal. So we can rewrite 1/2 as 2 to the negative first. And then we can set the exponents equal to each other and solve for x. Okay, let's take a look at log base 2 of x minus log base 2 of 11 equals 0. Similarly, if log bases are equal, then their arguments have to be equal. So if I have log base a of b equals log base a of c, then b equals c. Let's solve e to the 3x equals 15. So remember that for f of x equals e to the x, f inverse is natural log of x. So we can take the natural log of both sides, and since natural log is base e, and when we compose inverses we are left with just the input, showing the power rule for logarithms there, so the 3x is in the exponent of the argument, so it can go out front. So the natural log of e is 1. So we have 3x equals the natural log of 15. Isolate x by dividing by 3. So x is the natural log of 15 over 3. Okay, now let's solve the natural log of x equals 8. Remember that natural log of x is log base e, so if we transform this to an exponential equation, we would have x equals e to the 8th, and that's the answer. We can also think of it as exponentiating both sides, so e to the ln of x equals e to the 8th. Either way you want to think about it. Okay, so then we have an exponential equation. 7 and 13 cannot be rewritten as the same base, so what we did on the first example, where we rewrote the bases to be equal and then set the exponents to be equal, we can't do that. So we can, however, use the power property from logarithms and take a log of both sides. So let's use log base 7 and then the change of base theorem to write the answer in terms of common log. So if I did log base 7 of both sides, the reason I choose that is because we have 7 to the x. And on the right hand side we'll have log base 7 of 13. Just like e to the ln of x, log are inverses, so you'll just be left with x, like on the previous example. The opposite is true when you compose an exponential inside of the logarithm with the same base, so you could show the power property that x comes out front, and log base 7 of 7 is 1, so x equals log base 7 of 13. Now let's say that we wanted to maybe change the base, so change of base theorem. Let's recall that. Is if we have log base a of b, that is the same thing as choosing a new base c, log base c of b over log base c of a. So we could rewrite log base 7 of 13 as the common log of 13 over the common log of 7. And you could do that with any base. I just chose common log for that example. Okay, this is an equation in quadratic form. So notice that e to the 2x is e to the x squared minus 4 e to the x to the first plus 3, and that would technically be e to the x to the 0th power multiplied by that 3. But we can say something like, let's just pick, I don't know, t. Let's say t is equal to e to the x. So then we would have t squared minus 4t plus 3, just to make it look like something other than that exponential equation that we can solve. So t minus 1 times t minus 3, and the zero factor property is t equals 1, t equals 3. Now t was just holding the place for e to the x. So e to the x equals 1, or e to the x equals 3. Now we have to solve this equation, e to the x equals 1. So take the natural log of both sides, so natural log of e to the x equals the natural log of 1. The natural log of e to the x is just x, and the natural log of 1 is 0. And then let's finish this one out. So the natural log of e to the x equals the natural log of 3. X equals the natural log of 3. Okay, and let's take a look at something that is going to use the product rule for logarithms. So if we have two logarithms with addition, and then they have the same bases, we can rewrite that as a single logarithm with multiplication. So the reason we would want to do that is because we have log base 3 of 16 over here. Now remember, if log base a of b equals log base a of c, then b and c have to be equal. So this must be true. And we end up with a quadratic equation which we can factor into x minus 8 times x plus 2. So the proposed solutions are x equals 8 and x equals negative 2. So if we go back and look at the original, x, if we chose x to be negative 2, up here, negative 2 would be the argument inside a logarithm, and that does not exist. So negative 2 is not a valid input because we just have x right here. And then we'd also get a negative 8 right there. But x equals 8 is a valid input because the argument has to be positive. And so if we put an 8 right here into the original, we put an 8 right here into this one, we wouldn't have any domain errors. So x equals 8 is the solution. A lot of solving equations in this section, and then we're going to apply it in the next section.